Howdy. Number two. It's this kind of reddish rock with this black thing there. And I know it's not the best picture, but just to prove that it's number two. So here is number two. It might be nice. It's exactly the same like number one. It's nice where we have quartz, and hematite is making it appearing brown. No radioactive material found. That's the same rock, a better picture quality. I call this part here the bark because it looks like bark from a pine tree or something. And there are those, here's one really easily to spot. And there's like this kind of gold dust all over everywhere you look. As closer you look, the better you can see it. Like really fine. And this looks, to me, it has really a barkish appearance. That's the front. And obviously it's not polished yet. And you can see the distinct boundary of this blackish part, and also the big graininess of the whole piece. So I tried my best to get a small, thin slice of that rock with this kind of little machine, and I managed to cut off a small piece, and I was about to grind it by hand that it's smooth on the surface, but it broke into many pieces immediately. So it's not the best picture, I know, but it's a really small piece. And I guess that's the first piece, because I didn't remember to take a picture of how it looks. But that's under the microscope from the same stone. You can see somehow this kind of structure inside the rock. And since it wasn't possible to grind them flat, as you have seen in the picture before, there are these kind of grains, and I don't have any tools to grind them down. This is the piece what you saw just before in the picture. So that's a grain from that stone. And I'm really intrigued by these features, because if that's quartz, that's somehow really messed up quartz, that's not grinded in any way, because it's really small. And this looks like glass in a way. And the reason why I took a piece of that, I wanted to see if there's any possibility to see if there would be anything which would relate to shocked quartz. And if they were talking about perpendicularity and shocked quartz and these kind of things, here we have some perpendicularity features and also featherly features. Then it's really hard to get one piece or one part of it nicely focused because it's a grain. It's a 3D. It's not flat. It's really hard. You just get a really small part of it sharp. And I don't know. At least to me, this looks really, really interesting because this is just one really small grain. There are bigger grains in this piece of stone. And they all, like you can see these kind of features sometimes even already with bare eyes, I would say. That's a video. The reason why I took a video is that you can see, like when I zoom through it or how it moves, how other, like different parts of the piece get visible sharply. Yeah, this would really look interesting, I guess, if you could grind this down to a flat disk and you just would see the patterns in 2 dimensions. So these patterns go through. They're not just like on the surface or something. They are a part of the whole really, really small piece, which is about 1 millimeter in diameter or something. 2? No. 1.5, probably. That's just a picture of the structure. And it's really, really intriguing. Like here again, this kind of feather structure. Remember that. And maybe also these kind of features are from importance, how it refracts the light. There's more down here. And some of those black dots may be just dust on my microscope. Yeah, sorry for that. That's a video as well. And these black things are like in the stone, they're not dirt. As you notice, they get sharper and less sharp as I zoom through the stone. These black features are in the rock. And just alone the structure of this really small piece of rock is really intriguing. With all these shapes and stuff. Yeah, that's with the light from below. I would say it has at least feathery structures to it. There are many interesting parts, and it's really hard to take proper pictures. Or just move the stone a bit that you can take a sharp picture from another place, because, you know, moving it a tenth of a millimeter is not an easy task. Yeah, this I tried somehow to get closer, because there obviously there are two things there. Oh, yeah, there's a lot. I know. But yeah, that's really small. So small it's not even sharp. Yeah, check it out. It's broken. But anyway, I leave it here. Actually, I don't. Because I still wanted to share this quickly. Libyan desert glass area in western Egypt shocked quartz in bedrock points to a possible deeply eroded impact structure in the region. Now let's go to search for some picture. I will put a link below. You can check it out. This is how it looks where they were digging or found. Big grains, quartz and stuff in the middle of the desert. And here are the sample pieces they took. Yeah, actually, I wanted to show you about the PDFs. Where was it? They explained the thing. High temperature mineral. Somewhere they had explained what those PDF and stuff mean, because, oh man. Yeah. Shock deformation features in quartz grains at relatively low pressures, planar fractures, PFs, and feather features, FFs, form. Whereas planar deformation features, PDFs, form at somewhat higher pressure. Okay, this is why I mentioned the featherly-like structure. Now let's search for some pictures, because there has been some pictures under the microscope. Here we have those perpendicular features, what they were talking about. B. A, C. Where is the B? Thin section of monomict quartz brachia sample LGD 2006-14 large quartz grain showing one prominent set of PF. D, but they don't talk about the B. Why? This would be the most interesting. This one here. Yeah, I would be really interested what they would think about this stone I had just now showed you here. Conclusions: Libyan desert glass is an unusual type of impact glass. which occurs over a fairly wide area in western Egypt near the Libyan border. The glass fragments, mostly wind-polished and abraded, range in size up to a few tens of centimeters. The origin of the glass, which was described in the middle of the 19th century, has been the subject of much debate, and many different and often rather exotic processes were suggested, including a hydrothermal Solgel process or a lunar volcanic source. Indications of an impact origin include the presence of schlieren and partly other completely digested minerals such as lecatelierite, beryllite, the former presence of radite, and the presence of a metallic component in some of the glass samples. However, more recently, the possibility that these glasses formed from high temperature melting due to air burst explosion of an extraterrestrial object such as a large meteorite in the atmosphere has been discussed. Okay, so they probably think it could be possible. And they maybe also should know that if there's an object entering Earth's atmosphere, there's an electrical discharge happening. That's why they're exploding. Because Earth just has more energy than the meteorite. It's just overpowering it. Simple. It just depends also on the angle. If it's really steep, it might impact, but usually they just get pushed away. So the question remains, did I find some shocked quartz? Is this shocked quartz what we are looking at here? Feather structures like in the picture we have just seen before. I don't know. If someone knows, tell me. Thanks. Bye.